Welcome, everyone. Thank you for choosing to stay this hour with us. It's truly a pleasure and an honor to standing in front of you to share this session. We know it's day 4 of reInvent. After lunch, lot of walking between sessions and hotel. By the way, anyone hit 10,000 steps a day during this week? Wow. I hit 15,000 yesterday. Trust me, I can feel it too. So good news, this is not going to be sit and listen session. We are keeping things interactive, live demo, so please feel to interrupt us if you have any questions. So welcome to our session, COP418, monitor the quality and accuracy of your generative AI workloads. I am Ganesh Samanthan, Senior Technical Account Manager with AWS. I support strategic customer segment with AWS. I've been with this company for around 4 years now, also a cloud operation technical field community member.
I'm Raviteja Sunkavalli. I'm a Senior Solutions Architect with AWS, specializing in cloud operations. My fortes are observability and incident management.
Awesome. Together, we are going to explore some interesting topics today. AI, of course, AI agents using Strands SDK, and also CloudWatch GenAI observability, how you can leverage all these tools to run your AI systems at scale in production. This is the quick agenda for today. Introduction to agents. We're going to talk about AI agents, evolution of AI agents, what is the current state. Then we will discuss about observability, why it is absolutely critical to have observability for AI agents. Then the fun part, we are going to show live demo of AI agent, how to build AI agent with Strands SDK. Then we are going to explore CloudWatch GenAI observability, how you can ingest metrics from AI agents to CloudWatch and monitor them. Then we are going to show a couple of common troubleshooting steps that you face in AI agent. Finally, we're going to share some resources that you can explore after the session, live code samples that will help you to build AI agents with confidence. So, generative AI has come a long way, right? Back in 2023, we were discussing about chatbot, how prompt engineering works, how RAG systems work. So it was a year of exploration, proof of concept, right? Then came 2024. We started to adopt few AI capabilities within our application. But then the discussion has shifted from how to use this AI agent securely, to be responsible AI, right? And then now we are in 2025, AI is everywhere, right? All the applications want to enable AI. All the enterprise companies want to see the real automation, business value out of AI. So here's the interesting part. Building an AI agent is fairly straightforward, or at least less complex. But observing them is a real challenge, right? And to give you more options, here at AWS, we provide Strands SDK. And you can see there are some famous frameworks available, like LangChain, Crew AI, where you can use to build AI agents. All these frameworks have different advantages, capabilities, right? Again, with all the popular frameworks, everything, building an agent is a straightforward thing. But again, when you deploy this AI agent into your production with tens and thousands of AI agents, it's extremely difficult to observe, monitor those AI agents, right? And customers have told us that to have the complete view of AI agent from start to end, monitoring the request is extremely difficult and challenging. To solve this challenge, we provide Amazon CloudWatch GenAI observability, right? So what is Amazon CloudWatch GenAI observability? So it is a curated insights metrics out of the box. So you have all the critical metrics like invocation threads, latency, token usage, everything in the same place. So you get 360-degree view of agent workflows. Then zero code instrumentation. So we use OpenTelemetry to instrument your AI agents. So it can send telemetry to CloudWatch, and you can monitor those. And then end-to-end prompt tracing. So basically, you can trace the entire iteration of your AI agents, where how AI agents initiate your LLMs, uses the RAG systems, right? So you can track all the requests from start to end. Then data protection policies. So we have inbuilt CloudWatch data protection policies where you can use to mask your data and to have compliance for your data ingestion. And then finally, the new capability that we launched on Tuesday during our CEO keynote, evaluation metrics. So what is evaluation metrics, right? It's basically monitoring your AI agents to make sure it is doing the right thing at a right time in a right way, right? So we have some scores and the prompt that you can use to evaluate your AI agents. We will show more in the live demo. So now that you know CloudWatch GenAI observability, one of the biggest advantage of CloudWatch GenAI observability is its flexibility. No matter where your AI agents run, whether it is in Bedrock Agent Core or EKS or ECS or Lambda, you can integrate CloudWatch GenAI observability, and you can monitor your applications, right? So that flexibility will give you to monitor your AI agents across your infrastructure. So as we discussed about CloudWatch, what it monitors, let's dive more into how it structures what it tracks, how it monitors all your metrics, right? So at the top, we have session. So think of a session as the complete conversation between user and an AI agent. So for example, in the chatbot, if you ask any questions, so from the start to the end, that is session, right? So under session, we have traces. So think of a trace is as the one conversation from one request and one response. So all the things happen in between, we track it with traces. So under trace, we have span. So span is nothing but it tracks all the individual tasks that is happening within that interaction. So basically, it is like parsing your user request or initiating the LLMs, right? So it tracks all the metrics related to that. So under span, we have subspan. So subspan is a fine-grained detail, like single API call or retrieving the user or initiating the LLMs, right? So with all these key concepts like session, trace, span, subspan, you will get 360-degree view of your agents, how it performs, how you track with the evaluation. You will get complete control and confidence of how your agents run in production. So now that we discussed all the concepts behind CloudWatch and AI agent, let's move from theory to practice. So now Ravi is going to show us the live demo of AI agent and with CloudWatch GenAI observability. While Ravi is presenting, I will be around to answer any of the questions, so feel free to interrupt us if you have any questions. Ravi?
Sure. Awesome, thank you, Ganesh. Before we start, right, I'm gonna structure this demo into 3 parts. In the first part, we're gonna build a simple agent and run it locally, and then we'll see how we can add like tools to call, agent can call our microservices, and then we can deploy it to the runtime. That's the first part. And we're going to enable the observability and observe the entire telemetry in the CloudWatch, the new GenAI console. That would be the second part, and let's see some troubleshooting scenarios to monitor the performance of the agents. And in the third part, we'll monitor the accuracy of the agent using the new evaluations feature. Sounds good? So before we get started, I'm going to ask you a question here. How many of you have ever explored our AWS One Observability workshop before? Okay, I see a few hands raised. So those who have explored this application might be familiar. So we let customers do hands-on with our AWS and native CloudWatch, also open source tools like Amazon Managed Prometheus and Amazon Managed Grafana using this application called Pet Adoptions. So it has a front end and then 4 different microservices, which is like Pet Search is one microservice, Pet Food, Pet List Adoptions, and Pay for Adoption. And all the telemetry from this application will be ingested into the CloudWatch. Today, what we're going to do is we're going to build an agent. It's called Waggle AI, using strands. And we're going to deploy it to the Bedrock agent core. And we're going to collect the telemetry using AWS distro for OpenTelemetry SDK, and then ingest into the CloudWatch, and then explore the telemetry within the CloudWatch. So this is the code that we're going to explore. You can take a snapshot, and then we can kickstart our demo. All good. Can I move on to the demo? Awesome. First, let's understand the basics of the strands and understand like how easy it is to build agent using strands SDK. Like how many of you are already familiar with strands SDK and building agents using strands? Okay, I see quite a few here. So for you for those who don't know or like haven't explored strands, I'm going to give you a brief here real quick. Are you able to see my IDE? Zoomed in? Awesome. First, I'm going to import my agent module, which is used to build our agents. And then I'm importing my Bedrock model from Strands. Again, Strands supports any model from other third-party providers as well. But for the demo, I'm using Bedrock model. And the next one is I'm defining my system prompt. The system prompt is generic. So here I want my agent to use all the data from the trained LLM model, not like just tapping onto any other outside tools or APIs. Just a generic system prompt like, hey, you're a Waggle, a friendly pet food recommendation agent, helping pet parents find the perfect food. I gave other instructions how to approach for finding the food, and I gave some guidelines on how it exactly has to act. Think of this system prompt as a job description to your agent. So it has all the instructions what exactly it needs to follow. And then we are defining the agent instance itself. It's fairly straightforward. Open your agent class and then define your model. I'm using Bedrock and Sonnet 4 and using the model in the US East one. And I'm passing the above defined system prompt to this agent. That's it. Once you define, you can call the agent using this one. You can have an input here. Thus, it's as easy as building the agent using like Python. So for this demo, what I did, I had an interactive loop so that we can interact with the agent in the CLI. I'm going to save it. I'm going to run the agent here real quick. I'm going to ask a sample question, probably one from this. Okay, it's giving me some responses directly. It's calling our LLM, and it's using its pre-trained model and giving me some responses, right? But you don't know what exactly it's doing behind the scenes. That's where we need the visibility. So let's add some more concepts to it before we move on to the production. One is, instead of having the agent use its pre-trained data, I want the agent to call my microservices real time and fetch the data and then recommend the food. So for that, I'm importing a tool called HTTP request. With this tool, agent can make HTTP calls to my API endpoints. And then I'm importing Bedrock Agent Core app, which can be used to decorate our agent functions and deploy it to the Agent Core runtime. So those who are new to the Agent Core runtime, it's our new host where you can host your agents and scale your agents dynamically. And again, the prompt is similar, but here instead of generic prompt, I'm specifying a certain instructions. Hey, first get pet details from this endpoint where I have all my pets available. And then get the food details from this endpoint where I have all my food database in there. And then match the pet characteristics and consider the nutrition needs and provide clear reasoning for each recommendation. And again, some more instructions on how to give the responses back. Once that is done, you can initialize the Bedrock Agent Core app, and you can add an entry point. Earlier, if you see our earlier local code, all we did was a synchronous invocation, which means agent waits for the entire response to publish it back. But in the real time, if you're using chatbots, you have to stream the data. So that's why I'm using my asynchronous function here to stream the data so that my front-end chatbot can catch it and stream it live. Okay, now we have modified our code so that we can push it to the production. But where do we add the observability here? Do we need to change the code? Is it feasible to change the code like for all your agents? And it's a hassle to maintain the observability packages, right? So that's where we have our AWS distro for OpenTelemetry SDK. All you need to do is just add this package in your requirements file before you deploy. So you'll have your frameworks, either it stands or LangChain or any other third party. And you'll have your host frameworks. It is, right now I'm using Bedrock Agent Core to host. And then just add AWS OpenTelemetry for distro. What it does is, whenever an agent makes a call to either LLM, tools, or a RAG or knowledge bases, it kind of does a monkey patching where it intercepts the call, extract the telemetry like a prompts, metrics, and everything, and send it back to the CloudWatch. Once that is done, you can publish the agent in a different ways to Agent Core. The one easiest, simple way is we provide is Agent Core starter kit. You can install our starter kit and then configure the agent, provide the entry point, which is your agent code, and give us the permissions to publish it, and give a repository where you can create the images and then name your agent. That's it. So what it does is, once you configure the agent, it will create a Docker file, and it will open up a code build pipeline and run the code build pipeline, and then pushes the images to the ECR repository, and then it deploys the agent to the Agent Core runtime. So you can customize this as well. If you don't want to use starter kit, all you can do is you can create your own Docker file, create your images and push it to ECR, and then mention the ECR repository name in your API call, and then push it to the runtime. Once that is done, observability is enabled by default. Okay, all we had is about Agent Core. How about if you want to deploy it on the EC2, EKS, or any other host, right? How about you want to observe it in the CloudWatch? There are some couple of extra steps you need to do. Within the Agent Core, by default, we have this parameters pre-configured. But in the other hosts like EKS or EC2 or other, you need to export this environment variable to let the ADOT know that, hey, this is the place where you need to send it to the CloudWatch. For example, you are specifying a log group where you need to send the logs to the CloudWatch, and the region, and what's the protocol, and what's the OpenTelemetry distro that we are using. Here we are using AWS one, so you need to specify that, and enabling the agent observability. You just need to add these extra environment variables, and that's it. It works same as like what you did for Agent Core. So far, any questions on the Agent Core deployment? Sounds good. So let's move to the console here. For this demo, I have already deployed my agent, which is the pet food agent here. It's in the Agent Core. And this is the application that I'm talking about, which is pet adoptions, where you can see all the pets, and you can adopt a pet. You can pay for the pet, and then you can adopt. And you can also buy a food for the pet. This is where I wanted to integrate a chatbot so that customers can come here and chat with the agent to get some food recommendations. I'm going to open a chat here. So this is my new Waggle AI. I'm going to have a conversation with it. There you go. It's so excited to help us find the perfect food. Let me ask a question here. I have a Max, black puppy of 2 months old. Can you suggest some good food for it? So it makes some interesting decision at the back end and gives us some response. So that's where we need the observability for, like, we need to monitor what exactly the decisions is being made by the agent at the back end. So it gave me some response here. So, okay, let me help you find a food for a little Max. First, it is searching for Max in our inventory. and then it will find some great food. Okay. In the next line, it found several black puppies in our database, and then it is searching for the food, and it gave some recommendations like some beef and turkey kibbles and raw chicken bites. So let's see if those two food are available in our database. Let me open it in a new tab. There you go. So we have beef and turkey kibbles and raw chicken bites and then puppy training. So we have 3 foods, and it recommended the top 2 as we instructed. And again, you can see for kitten, we have some other foods, and for bunny, there are some other food. So it means it's working fine, but let's see how it is making that interesting decisions at the back end to find the right food for our customers. I'm going to navigate to the new CloudWatch dashboard. So this is a new CloudWatch where you will have the GenAI observability. On the left-hand side, we provide 2 dashboards. One is model invocations, and the other is Bedrock Agent Core. For the model invocations, you need to enable the Bedrock model invocation logging. So what it does is, let's say if you are using Bedrock models, it will give you all the GenAI golden signals. I will call it as like an invocation count, latency, tokens, and also you can see the input and output of each request for each Bedrock model. So let me click on a particular request here. So you can see the input here. It's my system prompt. And you can see the my user input, like I'm asking you to buy a food as well. And you can see the model invocation, what exactly. So you can see all the model, each request input and output. If you go on to the Bedrock agent code, this is where you can view all your agents hosted on multiple platforms in a single pane of glass. So right now, I do have 2 agents that are invoked in the past 12 hours. So you can see the list of agents and the environment where they are hosted, and then number of sessions that are run. Oops. And then the traces, and if there are any errors and any throttles, you will see all this in a single pane. And also you can see the runtime metrics. This is only for the agent core hosted one. So you can see the runtime sessions, invocations, vCPU consumed, and also memory. So you can click on one of the agent here. So the pet food agent is what we interacted with. I'm going to click on here. So this will give you a detailed view of a particular agent. So you can see there are multiple pre-configured widgets here, errors and latency by span, number of sessions and traces again for that particular agent, and then foundation model token usage. Right now I'm using Sonnet 4. You can see the time series graph of the token usage, like inputs and output. And if there are any client errors, throttles, you will see in this pane. Now, if you want to dive deep into the session, you can go to the sessions. I'm going to grab my session ID. In my front end, I have my session ID here. I'm going to filter my session ID. It's going to take a time since it's filtering like 12 hours of data. There you go. Once you click on the particular session ID, you'll see all the traces. Each trace is an interaction. Think of it as a question to the agent itself. So here, I've asked 2 questions. One is, hey Waggle. The other one is one more question. I have a max n. So this one would be 1 trace, and this one would be 1 trace. So let's go back and click on one of the trace here, which will open up a side panel where you can see the trace metrics, how many spans are in that particular trace, what is the latency, average latency, and how many tokens. And if there are any errors, you'll see the errors here. And the most importantly, we have the new trajectory map. You will see the entire choices made by the GenAI agents in a visualization here. For example, I invoke my Waggle API. So it invoked Bedrock Agent Core runtime, and then it invoked Stance agent, and it had like 3 loops. In the first loop, it searched for the pets. That's what I instructed in the system prompt, if you remember. Where is my prod? There you go. You can see the first process is to get the details from this API. That's what it did to get search for the pets. And then in the second loop, it is getting the food. In the third loop, it is sending all the inputs to the LLM, and then LLM is giving the recommendations based on the data. Now you can see the entire conversation by clicking on one of the chat spans. There you go. So first, you can see the system prompt. And you can see my user prompt and what is the agent responded with, and a turn-by-turn conversation. And now I asked again one more question. I have a max. So you can see the max here. And what's the assistant message? And what's the tool message? So the tool, it invoked my microservice to get the pet search results. So it gave me the entire database in a JSON format of my pets, the age, and the URL. And then what it does is it will be inputted as a user message to the LLM so that LLM can process it. Now it will become the user message. And then now the assistant says, hey, I can see all my adorable black puppies in our database. Now it found the puppies. Now it's looking at the food. Again, it called a tool. It got the response from my microservice. And again, it is inputting as a user message to the LLM. And then it is making the interesting choice here. So you can see the entire conversation in your CloudWatch Observability dashboard. It's very important to see what your customers are seeing. And again, we have like quick filters here. Let's say you want to filter with any spans that are any errors. Right now, we don't have any. With any high latency, you can exactly pinpoint at which hop it is taking more time to give the responses back to the user. Is it taking the first hop or when it's calling any tool? So you can view all the details here. And also each LLM for each LLM invocation, you will see the input and output tokens here. How many tokens the LLM is using, where then you can set up some alarms where if it is crossing a certain limit that you are not expecting, you can set up an alarms to trigger and you can do an investigation from here. So the first resource gives you like code samples on deploying the agents on other platforms. Today we saw on Agent Core, but if you want to play it out like Agent Core, EC2, ECS, and EKS, this is the first one. And the second one, I think you asked the question like Stance, LangChain, and SDK. That's a great resource to explore the observability on our different agentic frameworks. And the third and fourth are documentation on the launch blog in case you want to get started with the generative AI observability. Thank you so much. Please feel free to leave the survey feedback in the application.